This Hangout on Air is now live. All right, so we are live and being recorded. We have 0 viewers right now, so let's wait until we at least have 1 viewer.
Okay. Yeah. Okay. Maybe they can't get in.
They should be able to get in now. I see on the other screen that it's saying that it's live, so people should be able to start clicking on it.
Okay.
This is where we need the elevator music and some sort of slide show to.
I've got Jimi Hendrix here on a CD. I'll just put that on. I'd be dating myself seriously with that.
No, it's timeless. All right, we have 1 viewer.
Okay.
Hello to our 1 viewer. We have about 11 people that have registered for this, so I think we're going to wait a little while for a couple more people to join. I think it might be Dorota who's joined. She just sent an email.
Sorry, who?
Dorota?
Oh, yeah.
Okay. Whoever is watching, should be some Q&A functionality. So if you want to test that out while we're waiting, feel free to answer a question, and I'll be able to see that and confirm that people are here. Two viewers now. 3 viewers. All right, well, we have three viewers right now. Let's may as well get on with it. So hello, I'm Cody Baker. I'm one of the executive team members from the Division of Energy Efficiency and Renewable Energy. This is webinar number 2, so we're still trying to get our feet wet with doing these. So there may be some technical difficulties along the way, and we're trying to work through them. This platform does allow us to have questions being asked. So I can see that Dorota just asked a question. So I would just simply select that, ask our presenter to answer the question, and then click done when it's done, and it goes on like that. So today we have Seamus Frayne, Senior Project Manager and Technical Specialist, working in the area of wastewater treatment and processing, including biosolids, digestion, and composting. He was the project manager for the design team working with GICON and Harvest Power for the Harvest Energy Garden, which was the first high solids digester in North America, handling mixed food and yard waste. Prior to this project, Seamus was the project manager for the co-digestion project at Metro Vancouver Annacis Island wastewater treatment plant. Seamus is a member of the BCWWA and the APEC BC Division of Energy Efficiency and Renewable Energy. So I will now pass it over to Seamus. He'll say a few words and then get into his presentation. We have 5 viewers right now, so take it away, Seamus.
So good afternoon all. I'm Seamus Frayne, and I'm pleased to present this, our second webinar on behalf of DEERE. So just bear with me for a moment while I load the slideshow. So does that work? Okay. So
you haven't shared your screen yet.
Oh really? Okay.
you're sharing your screen now. Now you just have to hit present on PowerPoint.
Attention all staff, those of you who signed up for today's Lunch and Learn, it's now starting in the gross room.
Is that working?
Looks great. Take it away.
Okay, so I hope all of you can see this reasonably well. So as Cody explained, we're still working out some bugs and logistics with presenting webinars. This is our second webinar. And one of the minor issues here is that I cannot actually see questions on the moderator's screen, so Cody will read those out to me as they come in. And since it is a technical webinar, there will be questions, and there may be questions related to a particular slide or something like that, or something you don't understand. Please feel free to ask those as we go along. However, for questions of a general nature or for a broader discussion, I'd suggest holding on to most questions until the end and then asking them at that time. And then also, since we're always trying to improve here, I would also accept feedback, like comments, perhaps something you would like to see or something that you thought should be expanded on from this presentation that's just pertinent to this topic. So the topic is organic waste management and processing. And the emphasis, though, really is on the processing. What happens to food waste once it leaves your house in a bin or in a bag or wherever it goes. And since this is a lunch seminar, it's possible that some of you may be eating lunch as you listen. And if you are, you may occasionally wonder what happens to the food scraps once you're finished with them and you scrape them off the plate into a food bin. And it's likely that many of you do have food bins now at your offices or your place of work. And most likely these will consist of a plastic bag, a degradable bag in a bin. And this will probably be picked up every day, maybe every couple of days, and then it vanishes and a new bag replaces it. So what happens to that bag once it leaves your office? So the presentation today will follow this format. We'll have an overview of the organic waste diversion program in the Lower Mainland. And then we'll go on to discuss organic waste processing options. We'll take a look at what large communities do or should do and small communities. We'll also have some examples. And in this, we'll present the Harvest Energy Garden in Richmond, which is the largest local processor of organic waste material. And we'll also take a look at some other good-sized communities, what they're doing. And then I have a short a few slides on biosolids. I've included those because biosolids is organic waste and there's a lot of it. And the question we get a lot is, should this be mixed with food waste and processed together? And we'll talk about that a little bit later as well. Then wrap it up with a little review and a summary, and then open it up for questions. So on the Lower Mainland, there's been an organic waste diversion program in place for many years now, maybe over 12 years, I think, since they started diverting green waste out of the bins. And everybody, I think, is well familiar with green bins and with putting their yard and garden waste into a green bin. And this material is composted. And more recently, Metro Vancouver has advanced the organic waste diversion program and put some regulation in place. And as of July of last year, there's now financial enforcement for that regulation. And under the new regulation, the purpose of the regulation is to divert the food waste, for the most part, out of the garbage stream. And currently, there's under this program, there's going to be about 250,000 tons of organic material, and most of this will be high-strength organic material diverted from the garbage stream, and this is underway at the moment. And currently, there is in the range of 250 to 300,000 tons of green and yard waste, which is also collected separately and composted. So from July the 1st of this year, there is now financial penalties for haulers who arrive at a landfill or arrive at a waste disposal facility with more than 25% organic waste in their tip. And the penalty is 50% of the disposal fee is added for that load. So the penalties are quite severe, and they are driving diversion of food waste in general, and putting pressure on haulers and processors to come up with ways of dealing with this material. So the organics management cycle is going to look something like this. Separated food and yard waste will be processed using new technologies and some innovative technologies to extract energy and to return nutrients and compost back into the soil enrichment and the food production cycle. So we'll start to take a look at the technologies now for managing this organic waste stream. And the technologies and the remainder of the presentation really will be about one aspect or another of these technologies. So when you're dealing with large urban areas, typically you're going to have large volumes of concentrated food waste year-round, and the main options for dealing with that are digestion or composting. Digestion is favored when you've got concentrated waste material, concentrated food waste, because it's rich in energy, and also the food waste does generate good fertilizer value products when it's finished. You can digest it also. We'll talk about that a little bit later on. And then for smaller communities where the volume of food waste is small, typically in relation to yard and green waste, composting is really the only option for those communities. So if you take a look at that picture there, and you might remember that bag of food scraps that we talked about earlier from your food waste bin. This is probably where it ends up, what it ends up looking like in a tip or in a processing facility. It's a very unpleasant business, really, and you can see that the material is also, it's very messy, and it's also very odorous. I'll discuss some of these aspects of dealing with this later on. So moving on to digestion. As we said, digestion should be considered where you've got large volumes of high-strength waste, and especially solid waste. This is typical of commercial organic waste, commercial, institutional, and multifamily. And the quality can vary throughout the year, even from day to day, but volumes tend to stay relatively consistent. And with digestion, the objectives are energy recovery, material stabilization, and volume reduction. And the leftover material, we call it the digestate. It's still full of nutrients, and it composts very well when it's blended with yard and green waste for further processing. And the industry nomenclature that's developed for these digestion technologies is wet fermentation and dry fermentation. Now, I'll get into these a little bit more detail in subsequent slides, but typically wet fermentation facilities consist of tanks, and they look like the top of the two photos. And dry fermentation facilities they're not by any means dry, but the processing is carried on in a solid state in tunnels. So I like to show this slide to show some of the benefits of digestion and of the biogas that you can get from this organic waste material. So a cubic meter of biogas will typically contain 6 to 7.5 kilowatt hours of calorific energy. That depends on the concentration of methane in the biogas. It ranging from typically 60 to 75%, although some new facilities now for organic waste can get you up to about 80%. So very, very, very rich biogas. So if you have a 70% methane concentration in your biogas, It's equivalent to roughly 3/4 of a litre of gasoline, and obviously about 7.7 or 700 litres of natural gas. And if you could take this cubic meter and burn it in a CHP unit, a combined heat and power unit, you'd get roughly 2.2 kilowatt hours of electrical energy, and you would get about 2.8 kilowatt hours of usable heat energy. It's roughly 20 to 25% more heat energy than electrical energy. Then that doesn't add up, exactly to, it doesn't add up to 70. The rest is losses in the system. It's energy that can't be used. And typically this energy is regarded as a greenhouse gas neutral energy, and for that reason it has a higher value in the marketplace. Now, just to put some context on this and relate it back to the amount of organic materials that's going to be diverted. A common figure for the biogas that can be produced from a ton of mixed residential organics is 100 to 120 cubic meters of biogas. Now, that can certainly be quite a bit more depending on the material, but this is an average, a blend and it's a typical figure that's used in the industry. So if we were going to take the, say, 250, 260,000 tons of material that's expected to be diverted from landfill in the Lower Mainland here, and if we could isolate and digest even half of that, that would be the equivalent of 10 million litres of diesel approximately in a year. And that would fuel, back in 2002 anyway, it would fuel about 30% of the BC Transit bus fleet. It's a very significant volume of fuel. Anyway, to get into the details of the technologies, we'll start out with wet fermentation. So as we said, wet fermentation is one of the two processes really for digesting organic waste. So wet fermentation is digestion in a fully mixed tank. It's very similar, if anyone is familiar with sludge digesters at a wastewater treatment plant, it's a very similar process. The key characteristic of wet fermentation is that the feedstock is pumpable. Now, food waste requires extensive pre-processing to make it pumpable and mixable. And pre-processing is required to remove contaminants, to remove plastics, glass especially, metals, really anything that would interfere with the process and the end product. And then after these materials are removed, then the food waste is pulped. And as a pulped material, food waste is very non-cohesive, unlike sludge. So it can mix quite well at quite high solids content. And pre-processing typically, our pre-processing steps, which are shown in this slide here, they include a hammer mill is a common one to break up everything. There are flotation processes, separation by gravity also. And then the material is usually thickened a bit and then sent into then pulped and sent into the digesters. And in these wet fermentation processes, typically you end up with what we would regard as a very clean digestate, and this can be dewatered quite easily. And then in the dewatered state, you can then compost it for further processing, or you can dry it and pelletize it because it retains most of the nutrient content of the waste material or of the food waste that went into this material in the beginning. So some examples of these wet fermentation facilities. The City of Toronto has been using wet fermentation for years. They built a facility at Dufferin Road in Ontario, in Newmarket, which used to process about 30,000 tons a year of source-separated organics, but this has now been expanded to about 50,000 tons a year. And there is a new facility at Disco Road, which I believe is actually undergoing commissioning at the moment, which is going to process about 75,000 tons a year. And the bottom left photograph shows the older Disco Road facility prior to the expansion. And then the bottom right is the photo on the bottom left shows the old Dufferin facility prior to the expansion. And the bottom right photo shows the Disco Road facility as it was under construction. And the tanks you're looking at there are the digestion tanks. So this technology was provided by a company called BTA from Germany. The facilities are owned and operated by CGI Bioenergy under license or under contract to the City of Toronto. However, the city owns these facilities. Sorry, I said CGI owned them, but the city actually owns these facilities. Locally, we do actually have a food waste digester at Nanaimo, at the ICC group in Nanaimo. Unfortunately, I did not have a photograph of this, but this facility is operated for a number of years now, dealing with food waste and organic waste material from the regional district and the surrounding area. And then Harvest Power have a large wet fermentation facility in London, Ontario. This facility can process up to 100,000 tons of high-strength commercial food waste a year. There's a 2.8 megawatt electrical generator here. Power is sold to the grid, and the digested material is dried and it's sold as fertilizer. They get about over 5,000 tons a year currently, and this is not at full production yet, so that will increase. And this material has relatively good market value in the horticulture marketplace. I'll just move on and talk about dry fermentation. So dry fermentation is not really dry, but the key characteristic of dry fermentation is that the material enters the process as a solid and it remains solid throughout. And it comes out as a solid, albeit a very soggy solid. This dry fermentation was developed for this type of material. It was also developed for silage type crops that can be grown for this process to generate energy. It can treat source separated waste, and it's also a good product for mixed food and yard waste, or mixed food and green waste. In this process, the digestible substrates, the carbohydrates, the sugars, proteins, the fats, these are leached basically from the material, and they're concentrated in a liquid stream, which is then fed into a methane digester. And as before, the material that's left over, the digestate, the spent solids, they compost easily and they produce very good quality compost again when they're blended with yard and green waste. So the photographs here show photograph on the right shows a typical tip of mixed food and yard waste. This is what it might look like. And some is bagged, as you can see, some is green waste, some is just food waste. And this material is blended and it's fed into, or sorry, I should say it's pre-processed. It's pre-processed and it's fed into tunnels, like what you see in the bottom left photograph. And then these tunnels are sealed, and the fermentation process gets underway. Now this is a flow sheet for the dry fermentation process that's used at the Harvest Energy Garden in Richmond. So the Harvest Energy Garden is it's a relatively new facility. It went into operation about 2 years ago. It was built, it's owned by Harvest Power. It's called the Harvest Energy Garden. And the technology used here was supplied by a company called Gecon from Dresden in Germany. And this is their flow sheet. They call this the Gecon process. There are other dry fermentation processes on the marketplace, but I'm just going, for the purposes of this presentation, I'm only going to talk about the GECOM process. So a raw material is fed into into an enclosed building for pre-processing, and pre-processing means shredding to break up bags, burst bags, and to break up organic material like you saw in the previous photo. Big stuff like pumpkins or any large material that needs to be broken up so that it can digest properly. And this material it's structured with yard and green waste so that you create a porous, stable structure that's stackable, or material that's stackable. And that material is then fed into these long tunnels called percolators, or hydrolysis chambers in this flow sheet. And when a tunnel, it's filled into a tunnel using a front-end loader. And when a tunnel is full, the door is closed and sealed, and then the percolation process gets underway. And just for reference, for scale reference, at the Harvest Energy Garden, these tunnels are 30 meters long, they're about 5 meters wide, and they're about just over 5 meters high. So these are big structures. And the percolation process begins after the doors are sealed, and it really means spraying warm water over the top of the material, which then seeps down through it, is collected, and it's recirculated back through this tunnel to concentrate the material and to leach out the biodegradable substrates that are in the food waste. So as the material builds up and concentrates, a stream is fed off to a digester. In the GECOM process, the digester it's a packed tower digester, and just for our scale here, the material remains in a percolation tunnel for about 2 weeks. Material flowing through the digesters passes through these digesters in 24 hours. So the breakdown, the generation of methane gas is really a process, or the breakdown of organic material to generate methane gas. It's really a process of converting the substrates in here, carbohydrates, sugars, what have you, down through a series of steps into organic acids, and then finally into acetic acid. And this process is called hydrolysis, and generally this is an acidic process. It's not very strongly acidic, but it is acidic, and it works better when it is acidic. And the nice thing about this process is that that acidic process is separated from the methanization process, which is largely a neutral process and works best at neutral pH. So it's a very optimal process for breaking down organic material of this nature. So what does it actually look like?
Seamus, before you move on to the next slide, there is a question about how are impurities removed from the shredder?
Okay, that's a good question. So a lot of contaminants are not actually removed in this process, and I should have explained that as I went through actually. The large contaminants are removed. So if you've got large plastic crates, for instance, sometimes you can have drums coming in, believe it or not. You can have large pallets, for instance. Pallets actually would get broken up in the shredder, and pallets are quite useful in the process because they're wood. But plastics are not. Plastics are detrimental. And large contaminants like metals, again, those contaminants, or contaminants of that nature, are removed manually. They're pulled out before they ever get into the shredder. So, and that is a messy operation. But most other material, smaller materials, spoons, plates, what have you, they will end up in the shredder along with plastic bags, and they'll just be broken in the shredder or bent or whatever. And they will pass through, and they'll go in through into the tunnels, and they'll remain in that state in the tunnel through the process, and they'll be removed and put out in the composting in the same way. I'll talk a little bit more about that when we get to composting. But for this process, one of the key factors is that you don't need a lot of pre-processing. It's not at all like the wet fermentation processes, but you do have to remove large contaminants. Did that answer the question?
I think so.
Okay. So moving on to the harvest energy garden, this is what it looks like today. So in the photograph on top, this is the facility as it was just about completion of construction. Hopefully you can see my cursor here. There's an office building just to the left of the top photograph here. More or less in the middle of the top photograph, you'll see a tall concrete structure. You see a concrete structure, it's relatively tall. This is the receiving and pre-processing area. Between the pre-processing area and those tanks with the domed or spherical roofs or covers on them, you can make out a low-lying concrete structure. Those are the percolators. There's 10 of them in a parallel side by side in this process. Behind the digesters, there are the buffer tanks, what we call the buffer tanks. These receive liquid before and after digestion. And in the gas digesters, the high-strength organic liquid is broken down in the last conversion to generate methane gas. One of the interesting things about this process is that apart from the handling of the material using front-end loaders and whatnot to fill a tunnel, after that point, the only process step is actually the pumping of liquids. So one of the nice things, or one of the very beneficial things about this process is that it has a very small energy demand to run the process. In the bottom left, this is a view of the percolator tunnels. You can see roughly 8 of the 10 tunnels here. These are the entrance doors. The actual tunnels themselves are about another 2 meters higher, 2.5 meters higher than the doors. These are doors for the front-end loaders to pass through. The middle photograph is a view down through a tunnel. It's hard to see because the tunnels are all coated with a bitumen type of product. It's not bitumen, but it's bitumen style to prevent the acidic environment from breaking down the concrete. And on the top of that tunnel, you can barely make out the spray bars for the warm liquid that sprays over the material. And then on the bottom right-hand side is the CHP. That's a 1 megawatt unit there. And that electricity is sold to BC Hydro under a power purchasing agreement. Heat from this is used in the process, but there is quite a bit of surplus heat in this process, which currently Harvest Power don't have to use for the surplus heat. They would sell that to anybody nearby who had a process that could use it. So just some facts and figures now on the Harvest Energy Garden. The project receives about 40,000 tons of organic waste material a year, and which it processes, generating about 8 million kilowatt hours a year of electrical energy. And it's been in operation, full operation, since April of 2013. Now, for the Lower Mainland, there's a need for a number of these facilities. You can see This process handles about 40,000 tons, but if you remember, we have something like 250,000 tons of organic waste material to deal with. Double it when you add in the food and yard waste, so that's a lot of material. And in the Lower Mainland, there are a number of facilities, digestion facilities required to process the volumes that are coming up. And one of those is actually underway at the moment. The city of Surrey is building a 90,000 tons a year processing facility. It will also be a dry fermentation facility. They're using a different technology provider for that. That process was selected through a PPP purchase tender about 2 years ago. It will combine dry fermentation and also composting in tunnels. It's an enclosed facility. It's being built at the moment, and it will go into operation at some point in 2017. I believe it's early 2017, but I'm just not certain of progress. But even with that, there's still room for more of these facilities in the Lower Mainland. So just a quick review of digestion here. So digestion of organic waste, it's a good process when you're dealing with large volumes. You get greenhouse gas neutral energy. The solid waste digestate can be composted, or it can also be dried and pelletized. In either case, it yields a high quality product, a partial fertilizer which can be added to soil in general and put back into the food cycle. When you're dealing with food waste, odour is a major issue, and you absolutely have to plan for odour control and odour treatment when you're dealing with these facilities. And it's mandatory that the pre-processing be carried out in a well-ventilated but enclosed area. So digestion is typically it's a complex process. I think you probably got that idea looking at the photographs. And typically what we're seeing is the development of privately owned facilities which are operated under long-term contracting municipalities with disposal fees. And typically those companies are tied in with the waste management companies, because the waste management companies are largely the people with the haul contracts to get rid of the waste, and you have to have those companies on your side to keep a steady supply of material coming to your facility. Now I'll move on and talk about composting. Composting is also a process that works well with organic waste material, and it should certainly be considered. It is the process that's used for yard and green waste, but it can also be used for yard and green waste when blended with residential kitchen waste. It's very suitable for smaller communities where you've got a large proportion of single-family residences. You may also, of course, compost high-strength organic waste, but you do have to blend it with yard and green waste or a suitable bulking agent. It could be wood chips. You need a minimum ratio of 2 to 1 of this green material to the organic food waste. Your control parameters when you're composting for food waste are density and moisture. But you can see, looking at that ratio, that you would need a massive amount of yard and green waste or other bulking agent to compost the volumes that come out of a place like the Lower Mainland. So it's not really a practical option for large communities, in my opinion anyway. But there are large communities doing it. Composting is, from a municipal point of view, it's much safer, it's much less complex than digestion. And of course, when you're dealing with food waste, you still have odours. Odours are a major concern. And pre-processing, if you've got a lot of food waste, it really should be carried out in enclosed areas. And your primary composting should also be carried out in an enclosed facility. So I have a photograph here which shows a fairly typical, I think, composting operation. This is actually an aerated static pile, and what's being composted here is mixed food and yard waste. This photograph is from Washington State, I believe. So an overview of composting. There are 3 stages of composting which you need to plan for. There's primary composting, secondary composting, and curing. I'll talk a little bit more about each of those in the next few minutes. But one of the key things about composting is that you need a large area, and plastic contamination is a major issue for composting. And screening, composting, it usually does not, material for composting goes through some pre-processing. Again, you remove large contaminants, and you break up plastic bags if you have those, and you do shred the material, because frequently a yard and green waste can come in with relatively large tree branches, for instance, and material that needs to be broken down for composting. So at the end of composting, screening, all the compost is screened before it's either used or marketed for a final product, and it's at this stage that most of the contaminants are taken out. When you're dealing with yard and green waste, and even with food waste, there's very good public acceptance for this type of compost, and there's good options for bulk sales, for bagging it, for pelletizing it, and it has a good market acceptance and good retail value. Now I'll talk a little bit about each of the stages of composting here. Primary composting is the first 20 days, maybe up to 30 days of composting. When you're dealing with food waste and high-strength organic waste, you really have to enclose, you really should enclose the pre-processing areas, and the air from this and also from the compost itself must be treated. It's best also to carry out primary composting for these strong organic wastes in enclosed tunnels. And these photographs down below show some enclosed tunnels. These are from engineered compost systems down in Seattle. You're looking at the photograph on the right shows enclosed compost tunnels in an outside area. In the middle, you can see the same tunnels or similar tunnels inside a building. And then there's a photograph on the left looking down a tunnel. It's quite similar really to the digestion tunnels, although they are constructed differently, and you're trying to achieve different goals with these. These primary composting is when you get most of the breakdown of the organics, and most of the odor occurs during the primary composting. And you get best results when you can alternate the airflow between negative and positive directions. In other words, you blow through it or you draw through it. To get good airflow, of course, you have to have a structured material. So that's one of the most important things about composting, is structuring the material so that you get good airflow throughout the entire mass. And with food waste, it's even more important. The food waste has a tendency to gel, a tendency to stick together as it breaks down, and you have to avoid that. Especially composting, you have to avoid that. When you've gone through the primary composting, you go into what's called secondary composting. And secondary composting is a much simpler operation, really. You can have much larger stockpiles. Odors are still a concern, and you do have to aerate them. Very frequently, they're aerated either with negative aeration, so you draw air through the piles and then blow that air through a biofilter, or you can just turn the piles using turners, using large turners which are custom built for that process. Unlike primary composting, temperature monitoring is not essential. It's better if it's done in a covered environment, but it's not essential. And typically, secondary composting, you'll be 30 to maybe up to 50 days in secondary composting. And once you leave secondary composting, you go into curing. Curing is really where the pile is finished. It's nearly always done outdoors. Curing occurs over 60+ days, and in many areas, because there's no demand during the winter for compost material, these curing piles it's very common for the curing piles to sit through the winter and then be completely depleted in spring when demand picks up. They're not mechanically aerated. They are turned from time to time, as much less frequently than during the secondary process. And then the final processing of our compost is screening. And screening is usually carried out of a few levels. You've got coarse screening, which removes the larger wooden chunks, and all that material is returned back into the composting process. It's used to structure incoming material. And then you do finer screening, and as the screening gets finer, typically you remove more and more contaminants, and your result is a better and better quality product. And many companies at this stage, they will blend their products. They will add sand. They may add mulch. That stage, they're tailoring the products to a specific market. These bags you see here are a collection of products that Harvest Power produces. Some of these are marketed under the Harvest Power name directly. Others are marketed by other companies with Harvest Power producing the compost as an OEM product. So some examples of companies and cities that are composting. Well, the city of Calgary, believe it or not, is planning to compost its organic waste and its yard and green waste in a single large facility out of the Shepherd landfill. And the DBO, this is a DBO project, and the design of this project is currently underway. It will be going into construction, I think, next year, and it'll probably be operational by 2018. I've put in the flow figures there that the city gave out for their RFP process, which was conducted last year. They are going to compost biosolids here, about 4,500 cubic meters a week during the winter. And during the winter, they'll have about 3,000 cubic meters a week of food and yard waste. However, in summer, they will only be processing food and yard waste. That's the variation between winter and summer that they're expecting. The biosolids come from, these are digested biosolids coming from the Bonnybrook wastewater treatment plant. And they are not composted in the same, well, they're not blended with food waste at this facility for composting. When they compost them, they will be treated as separate streams. The city of Edmonton has a very large composting facility for their food and yard waste. Now, the city of Edmonton does not separate the food and yard waste at source, and the material it's segregated from the municipal solid waste at the West Edmonton waste management facility. So it's a heavily contaminated organic waste material. However, it is all composted in these these piles you see here, aerated piles. It's in a massive indoor facility. It's well worth a visit. It's scary. Interestingly enough, the city of Edmonton are changing their process, and they're moving to a digestion process for food waste, for their organic waste. They're going to use a dry fermentation process from a company called Biofirm, which is marketed by Weissmann from Germany. Hamilton, Ottawa, and Peel all have large compost facilities for their organic waste. Ottawa, I believe, may be considering digestion as well. And of course, Metro Vancouver, not to be outdone, does have a very large composting facility. Again, it's the Harvest Power Facility in Richmond. So if you look at the photograph on the bottom right-hand side, you can see on the bottom left of that photo where my cursor is, this is the primary composting for yard and green waste. Over here is secondary composting, and then in this area here is curing and sieving, curing and screening and stockpiling, all in this area here. And the bottom right hand side is the actual harvest energy garden for organic waste. It's quite small relative to the complete facility. So an overview or a review of composting. So it's widely practiced for yard and green waste and well understood. You can combine green and food waste, which you require a minimum ratio of 2:1 to get proper composting and odour management. It can be used for small or large communities, although with large communities and large volumes of food waste, you do have very stringent odour control is required. It requires a large area. It's not complex, and municipalities certainly have the capability to operate and run these facilities themselves. But as before, the trend appears to be privately run facilities operated under contract. So now I'll talk very quickly about biosolids because we're running out of time here. It's 12:50. But biosolids are available in every community that has a wastewater treatment plant. You're going to have biosolids. And the biosolids can be composted, and they are in many communities. They're composted. Dewatered biosolids looks somewhat similar to what you see in the middle photograph here. It has to be dewatered to about 20–25% is good. A little higher is better. It must be blended with wood chips about in a ratio of about 4:1 by volume. Otherwise, you can't compost it. And that's to correct the carbon-nitrogen ratio. And it's also to create structure to get air through it. So if you're composting biosolids, you must have a source of wood chips year-round. So on the other photographs, bottom left shows the Vernon Kelowna biosolids composting facility. In the covered building in the middle, this is the receiving hall where they receive biosolids, and they mix it with wood chips in this building, and then they move it into the composting areas, or the composting piles. Photograph bottom right is a finished product. This is quite dry. Normally it would be blacker than this, but this is a finished product with the coarse wood chips. You can see coarse wood chips in that product. That's prior to screening. After the material after this will be screened, and then that can be used. So I'm not going to say too much about composting of biosolids. It's generally well understood by the municipalities that do it. It's largely municipally run operation. But one of the issues with biosolids composting is that there is some public concern with residuals in biosolids. So there is reserved public acceptance to it. I don't want to say there's outright rejection, there isn't, but it is reserved. And one of the problems is that you actually cannot use biosolids-based compost in organic farming. And so if you're a municipality with biosolids and you're composting it, you must have a number of options for the end use for that, even though by regulation, Class A compost has unrestricted reuse options. Trends. Composting for biosolids, practical for small communities and fairly widely used. Not practical at all for large volumes and for large urban areas. And a trend for those communities is drying and pelletizing, and possibly marketing it if they can, or using it as a low-grade fuel. A quick overview. Yard and green waste can compost effectively. This practice will remain. Food waste can be combined with yard and green waste, but odour is a concern, and you must plan for this. Compost from yard and green waste and food waste has good public acceptance and good market value. Biosolids probably should not be blended with food and green waste in composting facilities. The products shouldn't be blended. I think it's okay to carry out the processes in the same facilities. You shouldn't blend the end products. And when you're dealing with large urban areas, I think digestion of organic waste certainly should be considered and has many, many advantages. And with that, I'll wrap it up and open it up to questions. And thank you for your attention.
Thanks, Seamus. There are no outstanding questions at the moment, but maybe we can give some people a couple minutes to digest everything and and come up with some questions.
Sure.
Yeah, it's interesting you were talking about public acceptance and reserve acceptance here and there. We were just at a event last night, the green drinks event, and a lot of people had a lot of questions actually about Vancouver's recycling program. And some people were noting that they had heard about odors complaints near the Harvest Energy plant. So it's going to be an interesting thing going forward, I guess, is how people deal with limiting the amount of odor. And
yeah, that's true. I think there are some extenuating circumstances at the Harvest Energy Garden. One of them is the fact that the facilities are just not there to process the volumes of food waste that are being diverted now. And so a disproportionate amount of it is actually ending up in the compost piles at the Harvest Energy Garden. But even with that, I think overall they do a very good job of odor management. And as other facilities come online, these problems should eventually attenuate and maybe not occur at all eventually. We're in this little period now where the demand is there, but the facilities are not.
so an extension to that is, what are some of the other challenges of operating these plants, such as vermin, birds, effluent?
Yeah, well, I'll start with the last one first. With effluent from compost facilities and even from the digestion facilities, from the dry fermentation process, you don't get a lot of effluent, and you pretty well have to marry the dry fermentation processes to compost processes. So you can use your effluent from the leftover effluent from dry fermentation. You can use that in your composting facility, because all composting operations require moisture. They generally have moisture added to them. So it's a benefit to do that, because there's a lot of nutrient value in that effluent too. And when you add it into a compost facility, you're retaining that nutrient value with the compost. So going back to a vermin, to say birds and to other vermin, yes, it's definitely a problem. It's a big issue where you've got food waste. We've got food waste in open, you're composting it openly without, what am I trying to say, in a non-enclosed environment. The problem is much less prevalent when you do your primary composting in enclosed tunnels. There's almost no problem with vermin, or well, there is no problem with vermin or with birds in those facilities. Secondary composting is much less rich in food. It's much less attractive. You still have birds, but you tend to have much lower level of problem with that. By the time you get into the cured product, there's really little issue with vermin, with birds in the cured products. That help?
Great. Yeah. So, any other major issues that operators need to deal with that we haven't thought about or spoken of? Yeah,
for the digestion facilities, the trend is very, very strongly for private ownership and operation of these. And It's largely a complexity-driven issue. Municipalities probably don't, and I think correctly, don't want to take this on. Larger companies who specialize in this can run a few facilities and do it quite efficiently, and they can have all the skills needed to keep them, to keep them running properly, and to manage issues as they arise properly. With composting, I think there's far fewer issues. Many municipal operations run their own biosolids composting and also their own yard and green composting, and I think they do it very successfully. I expect that to continue, and I think any municipal government that wanted to take on a composting operation could do it, and probably would be quite satisfied with the outcomes. Great.
Yeah. Well, there are no other questions, and we're at 1 o'clock now. So if you don't have any final last words, then I think we can end it here. So thank you to everybody that are still here. I see that we have had a few of our viewers just drop off in the last few minutes. So I think it was a pretty successful webinar. Feel free to join conversation on our apegbcdeere.ca, and let us know if this webinar format worked for you, and if there's anything that you would like to see covered in future webinars. Have a great day, everyone. Thanks.
Okay. Thanks all. Thanks, Cody.
Bye.